going to use the squeeze theorem to show that the limit is x approaches 0 of x squared cosine 20 pi x equals 0. And the way we want to do this is by graphing three functions: negative x squared cosine 20 pi x, and h squared, which is x squared, on the same screen. Alright, now the squeeze theorem says that if you have three functions that are all continuous at a given point, that's f of x, g of x, and h of x, where the f of x function is less than or equal to g of x, which is less than or equal to h of x. So in other words, the g of x function is trapped in between f of x and h of x. And if the limit of those two equal the same thing at a given point, then the limit of the one in the middle, the g of x, has to equal that same limit. Alright, so here's what we're going to do. We're going to define my three functions. So I have negative x squared, g of x is this weird one, the x squared, and you need to be careful about how you plug this in. Remember that cosine and pi are both capitalized, and then h of x is going to be x squared. So I define those three things. Now I'm going to plot them together. And this is really just an exercise on how to plot multiple functions together. And the way you do that is you make your plot function, and then you open up a list inside, and I'm going to list out the three functions that I want to plot. Just like that. So I have f of x, g of x, h of x, and we need x to go around 0. Let's get pretty close. How about negative 1 to 1? And hopefully this works. Let's see what happens. There it is. Okay, so now the blue is the first function. That's a negative x squared. H of x is the green parabola on the top, going like that. And the weird function that we're dealing with, this x squared cosine 20 pi x, is this yellow one zigzagging back and forth. So the squeeze theorem says this: f of x, as x gets close to 0, goes to 0. You can see that here with the blue curve. H of x, as x gets closer to 0, also goes to 0. You can see that with the green curve. The g of x function, which is trapped in between them, has no option other than hitting 0 at 0. And if we zoomed in really close, we could see that even better. So let's go in negative 0.01 to 0.01. Let's see what we get. You don't see the zigzags anymore, but you can see still the yellow is going to have to hit 0 because the other two functions do, which is what the squeeze theorem says. If you have any questions on this, let me know. I'd be glad to help. Mathematica is an awesome tool to understand these concepts better. Thanks for watching.